हाँ ठीक है। और ये लाइव
ठीक है।
हो गया सर।
हाँ ओके ठीक है। थैंक यू।
ग्रुप में लिंक भेज दीजिएगा वो इंडस बोर्ड वाले में।
लाइव अभी आप यूट्यूब पे, ठीक है।
हम्म। So hello everyone. In today's session, we are going to make a very small. We are going to design a smallest spy cam with the AI. The this camera is not only a spy cam using which you can spy it. It can give you the real time video streaming to multiple of devices simultaneously over the Wi-Fi. But also it will able to recognize the face, recognize the object, and do many kind of recognize the cars and many do other side such kind of AI stuffs. Okay. So for this design, we are going to use the Indus board coin because we are going to make a spy cam. So the camera might need to be a small. So we are going to use the Indus board coin. So this Indus board coin size is only this. And then we will over this Indus board coin, we will attach the camera. The camera module is OB2640. This is the camera module. So this is the camera module. Either you can use this kind of camera module or you can use any other this kind of camera module. This kind of camera module. So here I am using the other kind of camera module, the red one, this kind of camera module, because I need to make it a small. So this camera module and this is the Indus board, and we will attach this camera module for with the Indus board. But here for the DIY things and for the demo thing, I have attached it using the GPIO. Sorry, attach it using the GPIO. Attach it using the GPIO. The header pins just for the prototyping. But if you want to make it a small, like I've said you the small spy cam like, then you can solder this camera module these pins, this pin solder this camera module pins with the Indus board pins as I've told you later in the circuit diagram, and then it in this small size. In this small size, you can see you can compare with my smallest finger. In this small size, your whole camera spy cam will be ready. Okay, I just need to add a battery. So just need to solder the pins of this camera with the Indus board. Okay, and it will be ready. Okay. So okay. So the camera module that you need, the components you need is the Indus port coin, and then the camera module that you need is the this OB2640. Instead of Indus port coin, you can also use other boards, but other boards do not have that much of GPIO. So you have to find the GPIO, and those boards are very large size. So you can select it according to your choice. Okay. Here I am using the Indus port coin. Okay. So here I am using the this Indus port coin. And this is the display. You can also add the display if you want to add. I'm going here, but here in this demo, I'm not going to add the display. So this is, you can ignore this display. We are using only this camera module. The camera module name is OB2640 camera module, and the board is Indus board coin. Okay. So these are the things. So for attaching the camera module, this camera module work on the DVI port. So most of the other board based on the ESP might not have the DVI port. I don't know much about. I haven't tested all those boards yet. But here in this Indus board coin, I have tested this camera module with Indus board coin. It has a DVI port. DVI port helps in processing and getting the signals for the video based processing. Okay. For processing the video signals from the camera module. So DVI port integrated in this chip allowed us to make the make the spy cam and allow us to interface with the camera module. Okay. So let's talk about the connection, how we are going to talk, how we are going to connect it. So here is the circuit diagram. So before connection, let me show you the demo how it. This is as I have told you. This is not just a simple spy cam. This is the AI based spy cam. So it will also give you the AI data like image processing and all those things can detect the object and all those things. So here you can see here is the demo of the video in which Indus board pan is streaming the live video, and here I can select what kind of things I want to detect for the AI. And when I click on a start detection, it will start detecting that. I can see the video is being streamed from the camera and it detecting the person and all those things. And if there is a remote, then it will detect the remote and all those things. Okay. So this is how it will work. So it can either connect with the your Wi-Fi router or phone hotspot and give you the live video stream using that, or it will also create this AP point, and then you can connect your phone with this device hotspot, and when you search the IP address of that hotspot on the web browser, then it will give you the this thing. Okay, in both way. But here I am going to use the STM mode, that this will connect with my home router or my phone hotspot. Okay. So this is the connection of the, this is how we connect this camera module. This camera module with the Indus board point. Okay. So as you can see here, let me zoom it a little. Okay. So this is the camera module. This is the camera module. And these pins you see in this camera module are here. Okay. Are here. So first pin is the ground, and then we have the 3-volt pin. So this camera module will power with the 3-volt and ground pin. That is the 3-volt and ground pin of this Indus board coin as well. We have the 2 pins for the power on the Indus board. One is the 5-volt pin, and that will give you the 5-volt output. And another one is the 3-volt pin. Okay, that will give you the 3-volt output. So here our camera module needs 3-volt. So we are going to use the 3-volt. Okay. And then we have the SCL pin, that is the serial clock, and SDA pin. So you can either define the SDA and SCL pin in the code, or otherwise you can use the default SCL and SDA pin of the board. So this Indus board coin, if you check the pin of this Indus board coin, then the default SDA and SCL pin of this Indus board coin is the 8 and 9 pin. You can check. So as per the pinout diagram, you can see the 8 pin is SDA and SCL pin is 9. So SDA and SCL pin will connect to the pin number 8 and 9. Okay. Pin number 8 and 9 of this camera module. So then SDA and SCL, then is V sync, that is a vertical syncing line. It will refresh the vertical lines of the camera sensor. So you can define any line pin on the code. As per here, I am using the V sync pin to this V-Sync pin to the any of the GPIO from 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever the GPIO available. You can define similar in the code. And then we have the digital. It gives the camera module gives the data in 8-bit. Okay, so there are 8 digital pins are used here. So here there are D0 to D7 pin. That is the total 8 pins are there, digital pins, on which it will transfer the data about the image. Okay. And then we have the clock line DCLK, that will you can define in the code. And then we have the PWDN. PWDN here I'm not using. PWDN is mean power chip power down. So when you want to turn on the camera, turn off the camera, sometimes in the code you want is initialize the camera to be camera chip power to be the down. Okay, that means the camera chip power is in off position in the initial mode. Then you can use this chip power down pin. Otherwise, you can ignore this pin. Here I am not using this pin because we have already lots of wires. So I don't want to make the thing complex. So I have I am not using this PWDN pin. And there is another pin is called XCLK. So some camera module not have its own external clock crystal. Then you have to power the clock line from the board itself. So you have to use that XCLK to any pin of the board and use the board clock and feed the board clock generated from the board to the camera module. Otherwise, some of the camera module, like the camera module I am using, this red one, has its own external clock, has its own clock integrated inside the clock crystal. Okay. So here in the code, I have defined all these pins as per the circuit diagram you can see. So these pins are flexible. You can define whatever the pin you have connected there, you can define and connect it accordingly. Okay. So whatever the things I have connected here, the pins, these 3 volt SCL, VSync, SDA pin to the Indus board coin, I connect the same way. I define the same pin number here. Okay. So I have to connect the pins according to I have defined here in the code. Okay. So this is the whole connection. You can take the screenshot if you want. I am showing you the whole connection. So this is the whole connection. This is the connection that I have tested. Okay. On which I have done the code. Okay. So this is a tested connection. You can use the other connection as per your definition in the pin definition in the code as well. But you have to test it by yourself. This is a tested connection that I am showing you. So you can take the screenshot of that this circuit diagram for connecting the camera. That camera module is OV2640. Okay, this is the camera module. Okay. And I'm powering this camera module with the 3 volt pin of the board and the ground pin of the ground pin. And I'm using the default SCL and SDA pin, that is 8 and 9 pin of this board, to the SCL and SDA pin or default I2C pin of the camera module. Okay. And this 8-pin data pin is connected to the other GPIO. Okay. And there is a reset pin. This is also a auxiliary pin. It is also the optional pin. So if you don't connect it, it will also work. But if you want to some kind of reset, if I face some kind of problem with working, then you can add the reset pin. Okay. And then it's HERF, that is horizontal refresh line. Okay. So this HERF connected to this pin number 1. Okay. So I have connected according to this pin number, and whatever the wire you have connected, whatever the IO pin on the Indus board, you have to define similarly here in the code. Okay. So now let's go for the code part. So after this defining this pin, I have to connect all these pins on the Indus board coil like this. Or if you want to make a smallest SPI device, if you want to make the size smaller, then you have to solder this wire here. But here I'm not using the soldering wire because I want to show you the prototype and the connection. Okay. So all these wires are connected to this Indus board coil according to the pin defined here in the code. And if you want to also add the LCD, suppose that whatever the camera video is giving the output, you want to show on the LCD, then you can also attach the LCD to the boards. Okay. But here in this video, I am not using the LCD. Okay. So this is the whole connection. This is the whole connection as per the circuit diagram, and this is how the camera is connected with the Indus board coil. Okay, and this pin are defined in the code. Okay, now let's go to the code. Okay, so here we are not going to make just simple live video streaming camera that can stream the live video and act as a spy cam, but here we are going to AI based spy cam that will also able to detect the objects and person space and many other things. Okay, so for that, so let's go step by step. So first, let's make the live streaming thing, and then we will make the object detection in the code. Okay. So for here, for using the ESP camera, we are going to use the camera. So there is a library to call ESP camera.h. You have to include this library. We are going to use the Wi-Fi capability to stream out the video. Then so we are going to use the Wi-Fi.h. If you want to save the video on the SD card, then the code will be changed. And if you don't want to use the Wi-Fi, or you can simply show the video on the, if you want to simply show the video on the LCD display instead of Wi-Fi, then you can change the code accordingly. But here our motto is to make the spy cam, using which you can put this camera anywhere and it will live stream the video to your phone and laptop, whatever the device is connected to it, and also give you the detected object, detected person, and all those alerts based on that. Okay. And though we are using the Wi-Fi and hosting the web server on which it will host the live streaming video on the web page. So we are going to web server. So that needs another library called web server.h. Then we have the define the pin that I have already told you that we are not going to use the PWDN pin here. We have not connected the camera PWDN pin into any of the GPIO. So I have write it -1. So if you are not using the reset pin, then you can also write it -1 here. But here I am using the reset pin. If you are using the PWDN to chip power down pin in the initial state, if you want to add it and want to control the chip power down pin as well and turn on the camera, turn off the camera chip by turning the controlling the power of chip, then you can define the pin here as per your connection, whatever the GPIO connected it to. Okay. But yet I am not using that. I'm ignoring that. Then XCLK, like I've told you that our camera module has its own XCLK, that is external clock. It has own clock, the crystal clock cluster that will provide the clock frequency that will provide the clock to the camera module. But if your camera module do not have its own clock crystal and it has the XCLK pin, then you have to connect that XCLK pin to the pin number 44 or any other pin that you have defined. Okay, then your board itself providing the clock signal to the camera module. But here in my case, I have written the pin 44, but there is nothing connected to the pin 44. As you can see here, on pin 44 is empty. Pin 44 is empty. You can see here. Yeah, this is the pin 43, 44. This is a TX line is 44 pin. 1 minute. You can see pin 44 is the TX line and that is empty. Okay. So I'm not using that. Okay. And so after defining this pin, you have to define the in the code as we are going to use the Wi-Fi, it is going to connect with our router or phone hotspot. Then I have to define the SSID on which the router I have connected and the password of that router. Okay, if your router do not have any kind of password, it's open network, then you can simply leave this part blank. Okay, or you can simply comment this out like this. Okay, but if you have the password, then it will be better. Otherwise, if you connect this camera to the open, then this spy cam video can anyone be can be obtained from anyone. Okay, so there is a security breach here. That's why we need the password as well. If you want to be in the open network, then it can also be done by removing the password. Otherwise, it's better to keep it in password because the camera video being streamed over the Wi-Fi and it can be accessed to only who have the access to this Wi-Fi network. Okay. If you want to add more security layer to add, like even if anyone connect to this Wi-Fi network, but still he not able to get the video stream, then you can set the password for the web page. So first the web page will ask you the password. When you enter the password, then only it will show you the video stream. So that one more security layer can also be added. But here I'm not using that. I'm using the simple one. Okay. So to make you little bit more less complex. Okay. So next, after defining these pins, we have to define what are the function of these pins here. Okay, till here. What are the function of these pins? Okay, config pin, that is the data bit pin 0, Y1, Y2, Y3. These are data bit pins, and the external clock and the PCLK basing the TRF and a serial clock and digital line, all these things. Okay, till here. Okay. So till here, the pin definition is. Now next we will be here we are setting the external clock. So if you're using the external clock, like earlier said, if you are not providing if your module is not having its own clock crystal inbuilt on the camera module, then if you're providing the external clock, then you have to set the frequency of that clock frequency that you want to generate. You can set it here according to your need, according to the camera module specification. uh, Here, whatever the things I have written, it didn't matter because my camera module has its own crystal. Okay, it did not need external clock and it's not getting clock from the board. Okay. Next is the pix format. So here you can define the what is the pixel format that you want to capture. So there are different kind of pixel format that this camera module can capture. That is one is the JPEG, whatever you call, whatever the processor you call. I am not going deep into that. Okay, so let's call it JPEG for my sake of convenience. Okay, so one is the JPEG, then other was the RGB 565, sorry, and then other one is the YUV something. Yeah, here are the pixel format that this camera module support. Okay, so okay, So one pixel format that is support is the JPEG, that is the you already know. And then YUV422. This is another pixel format that will be support. And then we have the pixel format RGB565. That is the another pixel format that is support. And then is a grayscale. Grayscale will give you the black and white image. So if you want to do the faster image processing, or if you want to do the low quality video streaming just in black and white thing, then you can use the grayscale. And if you want to make it night vision, then you can also add the IR LED around the camera. That will give you the night vision. Okay. And then it will use the grayscale in the night vision will be great. Okay. So that can be done. That can be different modification that you can do according to different customization you can do according to your need. But here I'm not using that. Okay. So here in this video, we have given the option to the user that they can choose from the web page, like this web page I have shown you. Like here in this web page, you can see. You can see. Okay, there is no selection here. Okay. So either you can also add this one on the web page like this. Here you are getting the option now, default JPEG. So you can select the pixel format directly on the from the web page as well. You can do that option. You can add this option. But here in this version, I am not adding this. Okay, I am simply using the default that is RGB 656. That is the being easy for that. Okay. So you can set the pix format around that, and then then other one is the frame size. So you can define the frame size here, how much frame size you want. So if you increase the frame size, then you might face some kind of latency because the frame buffer is large, and and this camera this Indus board Quan has very limited amount of PS RAM, that is 2 MB of PS RAM. So if the frame buffer is large, there is some latency transferring the storing the frame buffer and transferring streaming it to the Wi-Fi network. So you have to select the frame size according in between the highest quality and the lowest quality in the middle. That will give you the better quality, but also give you the less latency. Okay. So if you want very fastest, then you can use the 96x96 frame size. You can define it like this, 96x96 frame size. Or otherwise, you can use UXVGA, RSVGA, or FHD. What are the other frame size? But those give you more latency. Okay, but the frame size will smaller and will become larger and smaller according to that. Okay. So these are the setting that here you can do. And here is the JPEG quality. What is the quality of image that you're going to capture? Okay. And FB count, here is the configuration where you going to put the frame buffer. So if you use the FB count 1, then it will try its best. The code will try its best to put the frame buffer in DRAM instead of the PS RAM. If you put it to the 2, then it will by default put the frame buffer on the PS RAM. But if your board has limited amount of PS RAM or do not have the PS RAM, some boards might not have the PS RAM. Yes, we board not, but here in this Indus board Quad have the PS RAM. It has the 2 MB of PS RAM. Okay, but if by chance some board have not have the PS RAM, then you can use it can store in the DRAM. Okay, so I am also using the DRAM and also using the PS RAM. So if the DRAM is not enough, then it can push it to the PS RAM. Okay. So that's why I'm using the frame buffer 1. FB count 1. If you change it to 2, then it will by default use the PS RAM, do not use the DRAM. Okay. Okay. So here we have the option of using this function. It will check the connection. First, it check the connection with the camera using SCL and SDLI. That whether camera module, the camera sensor is connected with the board or not, or communicating with the board or not. If it's not, then it will give the error why the camera relation is paired, where the error is. What is the error? Is the data line or the SCL line, the power line, different error you will get. If the so this will give you the all those details about the connection thing. Okay. And then we are going to stream the JPEG image to the to the web page. So we have to create a function where we can check with client is connected or not, if someone is connected to the board or not. If it is connected, then it will print the IP address on all those things, and then it will try to push the frame buffer to the connected client. Okay, pushing the frame buffer, whatever the frame buffer is coming from the okay. And then we have the next is the this one. This one is the HTML code. Okay. So this is one is the HTML code. This is the main code of our web page. Okay, web page code. Okay. So if I copy this, you can see if I copy this and run it on the HTML page compiler. Any HTML compiler, let's use this one. Oh God. So when I put this code, it will give you the whole UI, how our camera is going to look. Okay. But it's not going to show you the video. It will give you the error because at the no frame buffer is coming from the other side. Okay. So this will look like this. So in this area, you will get the frame buffer, you will get the video input, and here you will get the drop down option for what object you want to detect: person, car, camera, dog. And there are list of many objects. Okay, you can change this option in the code. Okay, and this is the what's it weightage, what percentage it will be higher up to which, so that it will detect it will take it as a, yeah, it's this is the person or whatever the thing. Okay, and you have the two option where you can start and stop the object detection. And here model loaded successfully. So when you connect the web page, the web page will start try to gather the download the model of object detection model in the web page, and then we will start in detecting. Okay, so if so it will take few time to load the model. Okay, it needs the internet connection in that way. Okay, so this is a whole web page, and this is the canvas on which the video being showed. Okay, so this is the HTML whole, this is the whole HTML code. This thing is the whole HTML code. So let's stand this step by step part of this code. Okay, so first is the in first two, we have using the JavaScript. This is a JavaScript code. Okay, so in this JavaScript code, what we are going to do is to download the TensorFlow Lite and TensorFlow JavaScript Lite model for the object detection, and that is the Coco SSD 2.1 model. So this is object detection model, that whenever the web page is open, wherever the web page is open, that a script will run out and download this SSD mobile net model on that web page. Okay, on that web page for the object detection. So first these two script will download the object detection model on the web page. Okay, whenever the device get connected, whenever the camera is connected. Okay, and next this is the all the CSS thing to make it beautify out the things. So configure the size, shape, color, page, and all those things, blah, blah, blah. You can simply ignore that thing as well. Then it will show you the basic like this one. But if you add the like this one, but if you add this one, then it will beautify and make it beautiful. Okay, so this is all the CSS part. This is all the CSS part. Okay. And there we have the video container, which will where it will stream the video. And there here in the here you can see the option select object, and there you have the ID to detect the person, car, dog, cat. If you want to detect the remote, if you want to detect the TV, if you want to detect the telescope, if you want to detect the cell phone, if you want to detect the battery, if you want to detect the a drone, whatever the things that is available for that model, SSD model that we have downloaded, you can change this option or add this option here. So if you want to detect support that remote, then I can simply copy this and add one more option to detect remote. So I can add more options, remove options, or change the options for the object detection. Whatever the object I want to detect, then that is whatever the object detection that is supported by this SSD 2.1.0 object detection model. Okay, SSD mobile net model. Okay. And then this is the score of object detection ID. Okay. And then we have the button to start and stop the object detection. If you don't want it will die by default start of detecting object, they can remove this button and it will not by default do the things. Okay. Yeah, so then it will load the model, and here I set in the code. If you want to make it flexible, then you can choose, you can change the code and make it flexible. Otherwise, you can keep this breadth and height to the 64 and 480 to make it look more larger and looks good. Okay. So these are all HTML part, and then we have the void setup function that will check the that we set up the Wi-Fi SSID password configured earlier and started the Wi-Fi and print you the name, and then using this function it will start the server. Okay, and here we have the function that ESP cam FB return that will take the camera frame buffer and return the camera frame buffer to this web page. So this is the all code. When you connect this Indus board point, when you connect this Indus board point, after that when you connect this Indus board point, okay, when you connect this Indus board point to this to here, and if it is in the Wi-Fi network, okay, we start streaming the video, and you have to search the you have to search the IP address there. Then you have to start streaming the video output, and okay, like this. Here you can see the object detection by the camera. Okay, like this. So this is how it will work. Okay, like this one. Okay. Okay, so here my Wi-Fi quality is little bit low, but let's try it out from my side. Let's try it out. Let's first connect it. This is for the live stream. Um, let's check if our if currently it is going to able to connect with the Wi-Fi network or not, because I'm not using the camera. I don't have the camera antenna right now connected with the board, and the Wi-Fi network is slow. So let's test it out whether it able to connect or not with the Wi-Fi network. If we get able to connect, then you can see the video and object detection. Otherwise, it will show you the connection. Connecting, trying to connect the Wi-Fi, something like that. Okay. So let's hope it get connected to our Wi-Fi network. Let's upload this code. So here the frame size and pixel format I have set it here. Okay, VGA and JPEG. Okay, this is the pixel size and frame buffer I have set. Here I have removed the display here, okay, from the camera. So now code is uploaded. If we get lucky and the Wi-Fi network able to catch the Wi-Fi network, then it will get connected. Otherwise, I have to add the antenna that will I can show you later in the demo. Okay. Now I disconnect it and reconnect it. Let's see if it get connected to the Wi-Fi network. Let it keep more closer to the Wi-Fi. So Wi-Fi network is very slow here. Or let me add the antenna. One second. Okay, let me add the antenna. Okay, let me add the antenna here. I'm just coming, getting the antenna. Okay, I have that. I have the antenna here in the box. I think here I have the antenna. So let's connect the antenna and let's try it with the antenna, whether it able to catch the Wi-Fi network or not. Let's hope the Wi-Fi network is nearby. It get connected to the Wi-Fi. Yeah, it's get connected. Thank God. And camera is nice, so I am okay. And then putting here. Yeah. So you can see the camera video streaming here of my room, and it's loading the model currently for the detection. Model loaded successfully, and when I click on the start detection, it will start detecting. So I am putting my face in front of me and it get detected. See, it's detecting. It's detecting. See. There is my face and it's detecting. Okay. So I have to tweak the frame buffer because it's little bit low. So this is how it's work. Okay. It will give you the real-time video streaming. Okay. So this is how you have to do. It will give you the IP address when you get connected, and you have to copy this IP address and put it in the web browser, and then we'll start giving the streaming. Okay. So this is how these things will work. Okay. So thank you. The whole project will be published in upcoming month of the electronics for you. So you can check there the design. Okay, and you can make this thing. Okay, you can also modify this thing for the various other functions. Like you can make a smallest camera that can attach to the drone, that is lightweight and attach to the drone and give you the live streaming with the AI capability and all those things. Those can be done. Okay, you can change it according to your will. Okay. Okay, bye. So if you have any more question, then if you have any more question regarding this project or regarding the Indus board, then you can. I am giving you. I am staying here for more 5 minutes, 5 to 10 minutes. So you can post your question on the WhatsApp. Mm, uh, on the YouTube or wherever you are watching, you can post your question. I can also post your question on the Indus board group. If you're from the Indus board group, I am checking the Indus board group right now. So if you have any question, you can post it there as well. I can take the question as well from there. Okay. So let me grab the camera. Let me grab the phone for that. Okay. Okay. Otherwise, I can access it from the. Okay. Let me stop the screen share first. Yeah, I have stopped the screen share. So you can ask the question here. You can ask in the WhatsApp group of Indus Board Coin as well. I am checking the WhatsApp group as well right now. So you can ask there as well if you have any more questions regarding these things. So I am waiting for more 1 to 2 minutes. If you have any question, then you can ask me on the WhatsApp group or on the YouTube or wherever you are watching. Okay. So this can be modified in many ways, and this can be designed in many other ways. And if you solder this camera, this camera to the board directly, then it will become very small. It will become this kind of a small device. It will become very small. You can ignore this wire. It gets soldered to the board and it becomes just this size, very small finger size spy cam. Okay, okay, and the whole thing can be fit in the box, like this kind of a small enclosure box. You can also use the thinner camera. This is a little bit bigger lens camera. There are OB2640 camera module that is bit thin and more small. Then you can use that as well. Okay. So if you have any more questions, then you can ask. So I'm not getting any more question. So I'm leaving here. Uh, so okay, thank you everyone. I'm ending the session here. If you get question later as well, you can post it in the comment or in the WhatsApp group. I will take that in the next session. Okay, and answer there.